here so that all the YouTube notifications go out and y'all swing by, and we're going to have an amazing show today. We're going to be talking about the up-and-coming Eclipse. And, of course, as always, Wayne is in attendance. We got him. J Mac, happy Easter. Nice seeing you out there. Oops, jumped the gun. Hit the wrong button. Alright, it's 1 minute past. We are going to kick this off right. And what is going on, ladies and gentlemen? I'm Frank, KG5AHJ, and happy Easter to y'all out there. We got an amazing show tonight, and we're going to be talking about the cool, awesome Eclipse coming up, and I can't wait. And then Windows is already dropping my mic. And we're just going to head and get it started off right. So we're going to play that what video? Awesome video! Before we get started on the up-and-coming video, I just wanted to take a second out to point out my new tank pad. These tank pads are being sold over at Corky QRP, and it has my logo too, along with all the HF bands that you commonly use when you're out doing a POTA. So this thing is awesome when you're out in a POTA. It's the perfect size for a mouse pad, perfectly fits inside your backpacks, and I love it, I love it, I love it. I can't recommend this enough. And to get yours today, head over to Corky QRP's Etsy shop and order now. Links in the description below, and it might be popping up right here. Who knows? Now on to Tank Radio. How y'all doing today? I'm glad y'all came out. I hope y'all had an amazing Easter, and probably still enjoying those Easter dinners. Thank you for coming out and hanging out with us today. As always, I am just going to do the quick rundown here at the top to say thank you to all my Patreons. I can't do this channel without y'all, and I really do appreciate all the support you give us and give me and help the channel grow. Buy me a beer and super chats are still active, and just go ahead and drop a super chat and I will read it out on air. And I will be also looking for questions throughout the interview, and I'll be asking them during the interview, or I might just save them to the end of the show, just as they fit in. The tank pads, as we just saw, are on sale over there at Corky QRP's Etsy store. They are amazing. US band plan. I love it. I love it. I love it. When you pick up one of those, it does help support me. And Gigaparts has 5% off at gigaparts.com. You enter tank at checkout and you get 5% on select items. Link is in the description below to tell you which items those are. And finally, my audio podcast comes out every week on my audio channel. So just go ahead and search Tank Radio in any audio podcaster app out there. I guess you can't do it in Google. Google took away their audio podcast. Now they integrated it all into Google Music. But I'm still over there. I checked and made sure, and it works. So this type Tank Radio, and you will find me. And there's 2 audio podcasts that you won't see on YouTube released over there. So just go ahead and find them, man. It's a great show. And today we are going to be talking about the up-and-coming Eclipse with Ham Science, and we got Gary coming on, and I had all the transitions ready to this point. Where we go? There we go. How's it going, man? How are you doing today?
Frank and all the listeners out there, glad to be here.
Thank you for coming, and I do appreciate you give us your time over Easter here to talk about the up-and-coming Ham Science, actual science we're doing amateur radio on the up-and-coming Eclipse.
Yeah, it's a big deal for us. Hamsci, I'll explain a little bit about what the organization does, but we're part of just taking space physics, which is kind of mysterious to a lot of people, but connecting it to amateur radio so that hams can learn and understand a little bit more about the world around us.
That is awesome. And I am going to be participating in this up and coming event. I can't wait. We are going to be down in Fredericksburg for the up and coming eclipse. And I'm going to be a receiver. And this is going to be so much fun. I'm hoping the weather holds out for us so I can participate and also see the eclipse. So I'm going to go ahead and give the floor to you here and for you to tell us about ham science and about this up and coming study.
All right, great, Frank. I'm going to share my screen. I've got about 20 slides to explain a little bit about who we are and what we do. And if that's looking okay, we'll get started.
That looks great.
All right. Hide my meeting control so I can see my own screen. Great. Today, I want to talk about the HAMSI Festivals of Eclipse Ionospheric Science and how we want to involve contesters, HF operators, even shortwave listeners, and general citizen science in some of our efforts. My name is Gary McKeaton. My call sign is Alpha Foxtrot 8 Alpha. Like a lot of you, maybe I've been ham about 47 years. I'm a degreed electrical engineer, but very lucky to have been retired the last 5 or 6 years. So now I'm a retired engineer and a full-time ham. So let's talk a little bit about HAMSci. HAMSci is the abbreviation for Ham Radio Science Citizen Investigation. We are basically a group of volunteers. We call ourselves a collective that allows university researchers to collaborate with the greater amateur radio community in scientific investigation. So we're not a business. We don't sell t-shirts or hats or high top tennis shoes or any of that kind of stuff to raise money. We're all strictly volunteers, though we do get some grants funding, and I'll talk about that a little bit later. HAMSI's objectives, first and foremost, is advancing scientific research and understanding through ham radio activities. In doing so, we always try to encourage the development of new technologies, new equipment, equipment that's affordable to the average ham. You don't have to spend tens or hundreds of thousands of dollars on scientific equipment to do what we do. Thirdly, also very important, is to provide educational opportunities for the ham radio community and the general public. So it's definitely, HAMSI is definitely got to be a two-way street. You'll see that hams, we create data and help the scientists, and the scientists feedback what they learn to us as hams. Pictured here is HAMSI at the Dayton Hamvention a couple of years ago, and below is our founder and still leader, Dr. Nathaniel Purcell, W2NAF, who's a professor at the University of Scranton. Well, let's talk about the main subject tonight, the total eclipse. Unless anyone's been living under a rock, we all know there's an eclipse coming up in about 8 days. And it's, for depending where you're at in the United States, you may see a total solar eclipse. This is a big deal for us and hopefully a big deal for you, because we won't see another total eclipse in the continental US for another 20 years. So get on the air, have fun, but most importantly, get out and take a look if you're within the path. I do want to mention, I talked about locating the path and knowing if you're able to view the eclipse. This is what I found to
Just
be the
real
best
fast,
website.
which slide do you think you're on? Because we're still
Ooh,
seeing. Um,
I should be showing the NASA Eclipse Explorers page.
no, we're still stuck at right now. I'm feeding back to you what we're seeing.
Okay, let's see here.
We're checking on that right now. Uh, Maybe come out of the share and re-enable it.
Okay, I'll stop share. It says my screen sharing is paused for some reason. Yep, maybe I hit a
Ah,
key. Let me reshare.
there we go.
A little better. Okay.
So try to there. Perfect.
Okay, so as I said earlier, unless you've been living under a rock, you're well aware that we've got a total eclipse coming up in about 8 days from this show, and it'll be the last total eclipse covering North America for 20 years. So get on the air, participate in our events, but most importantly, get out and if you're able to, view the eclipse. So hopefully we're seeing the NASA Eclipse Explorer site now.
Yes, sir.
Great. So this is the site that I found to be the simplest, easiest to use if you want to locate where the eclipse may be. It's got an area where you can type in your zip code. It'll show you how long you're in totality, if you're in totality. what times of the day, so on and so forth. It also does some nice videos of the eclipse moving across the U.S., which we can all see. Starts at southwestern Texas, goes across, it covers about 31 million people as it goes across my hometown of Cleveland and then off the east coast of Maine and then onto the Canadian Maritime. So think about if you're interested, you should be able to search on NASA Eclipse Explorer and find your way to this page. So, okay, so what does HAMSci do? I talked about scientific research. Our main area of study is the ionosphere. And hopefully to most hams, this should be relevant because I think a lot of us understand that it is the ionosphere that takes signals that leave Earth, bends them back to Earth, refracts them back to Earth, and allows us all to work DX, especially on the higher bands, 20, 15, 10 meters, and so on and so forth. It's the ionosphere that allows us to communicate over thousands of miles. Now, the ionosphere has some interesting properties. At night, it typically is down to only two layers. An effect called recombination occurs when we have an E and an F layer. But during the day, as the sun imparts extreme UV and X-ray radiation on the top of the ionosphere, the atoms and electrons and things get excited. The ionosphere turns into a plasma, and it separates into four layers. Many of us heard about E and F layer propagation. Some of us have also heard about the D layer. That's usually the bad guy. It's usually responsible for absorption of signals. But E, F1, and F2 help our signals work themselves away around the Earth. Now, one of the things we like to study, and I'll talk about this in a little more detail, is this day-night transition. It's not as simple as flipping a switch. And as we all know, in morning, it takes a while for the sun to come up and get fully risen. Same thing in the evening, it takes time for sun to set. So this transition from day to night is pretty interesting. It normally happens, as I said, fairly slowly, but during an eclipse, it happens fast. In a matter of minutes, we'll go from full daylight to nighttime and then back to day. I think hams have also heard about gray line propagation, and this is the time, this is the phenomenon, one of the things that we're trying to study. So as part of the study, scientists usually ask a few questions and they try to look for answers to these questions. And these are the things that we as hams can help with. The first and foremost is when we're looking at HF communications, who's communicating with whom? How far are signals propagating on eclipse day? Can the effects of the solar eclipse be observed in HF? Does 20 meters get shorter? Does 40 meters go longer? Maybe do 160 and 80 meters wake up during the eclipse because the sky is darkened. If we do observe those effects, how significant are they? Are they real subtle? Are they really hard to tease out of the data? Or are they very dramatic? Also, how long before and after the eclipse do we observe these effects? Is it just a few minutes before the eclipse passes overhead and a few minutes after? Or are those times stretched out and sort of elongated? And again, how similar are the eclipse effects to the normal dawn and dusk, what we call a gray line propagation? So these are just some of the science questions we're interested in. So just to step back a little bit, in 2017, Dr. Purcell had an idea that ham radio data may be useful during an eclipse. So in the eclipse that passed over the US 7 years ago, he did take a lot of data and did spend a lot of time analyzing that data and coming up with some pretty cool graphs. This colorful screen you see here is called a heat map. The reason it's called a heat map is the colors, typically the red ones and these darker browns, signify more activity. If you look on the scale over here on the right, you see this thing called spot density. With these higher numbers indicate more spots or more reception reports on things like the reverse beacon network or PSK reporter and WhisperNet. This time scale along the bottom is hours before the eclipse and hours after the eclipse. And the vertical scale is distance. Okay, so that's a lot to absorb. If you just take a look at this little spot here between 1,000 and 2,000 on the far left of the graph, that's telling us that an hour and a half before the eclipse, we had a lot of QSOs occurring in the 1,000 to 2,000 kilometer range on 20 meters. We can tell that by the colors. As you slide to the right, you're about a -1 hour, an hour before the eclipse. Things have not changed a whole lot. But shortly after that, you see the colors start to change. The colors changing indicates a decrease in the number of QSOs going on 20 meters. In fact, when you get to right near where the eclipse was overhead at this particular location, which I think was the center of the US, the colors are much cooler. The heat map is cooled off, and we're down in these greens and blues, and that's telling us we have fewer QSOs in that same distance range. So 20 meters really shortened up when it got dark during the eclipse. About a half hour after, things started to recover. You're getting into the darker color, more QSOs, more spots, and then about an hour to an hour and a half later, the band's more or less recovered. You can see that the colors aren't quite as dark. There aren't quite as many QSOs occurring in this range on 20 meters, and that's one of the things we'd like to explore further. We're trying to understand why things were different before the eclipse and after. So again, this is a heat map. It shows us 40 meters started out pretty strong that day in 2017. As the eclipse passed by, it shortened up. It was less good for propagation, but then it improved about an hour to an hour and a half afterwards. So this is direct proof that amateur radio data created by HAMS by making QSOs on the air, CW, FT8, so on and so forth, can be useful in scientific research. So, we want to encourage more hams to get involved, to create data and participate in our research. In doing so, we thought we'd kind of create an umbrella event called the Ham-Sci Festivals of Eclipse Ionospheric Science, under which we have a number of different events. The first and probably best known is the Solar Eclipse QSO Party. I'll talk about that, the Gladstone Signal Spotting Challenge, and a little bit about the Grape 1 and Grape 2 today. There's a whole lot more going on. The best place to learn about all this is hamsci.org/eclipse. So let's talk about the Solar Eclipse QSO Party. If you've ever done any kind of contesting, whether it's the hardcore guys doing ARLDX or CQ Worldwide maybe, or maybe even a state QSO party, or even field day, you've been on the air during a contest. Basically, hams making contacts, they're usually pretty short. The exchange is very quick, signal report, and 4-character grid square. That's where we're asking hams to exchange. Folks can operate CW or the digital modes. We've got a lot of people that like to operate FT8 these days. It's an ideal mode because every QSO on FT8, you do exchange signal report and grid square. That's how it's been for years, and that's what we're looking for next Monday. Phone QSOs are welcome as well, no question about that. And to make things a little bit more interesting, when it comes down to scoring this event, we not only look at how many QSOs each person made, but how many grids they worked on each band. What was the geographic dispersion of their contacts? And then we multiply those together and get a final score. The best way to participate is to use software such as N1MM Plus Logger. That's got a special, in the contest section, it's got a special setup just for the Eclipse QSO party. I understand that N3FJP in his contest module, I think it's the VHF contest module, just added the SEQP. And also folks that run WSJT-X, that's good software to use as well. Again, if you go to our Eclipse page, you'll find your way to the SEQP rules, and it'll talk about all these details. It'll give you a link on where to upload your logs after the contest and so on and so forth. So we really hope people will operate in the SEQP. Date and time for that, of course, is April 8th, and it is a 10-hour event. Now, we don't expect everybody to stay on the air for the full 10 hours, but we did pick these times with a very specific purpose in mind. You can see that the eclipse hits the coast of Texas, the edge of Texas, about 1700. Our contest starts about 3 hours before. That gives us some pre-eclipse sort of control data. And then it leaves Maine roughly at 2030, and it ends about 3 hours later, which gives us some post-eclipse data. So if you're inclined, operate all 10 hours, that would be great. If you only want to operate for an hour or two here and there, that's a good thing too. But whatever, if you're in the path of totality or near it, be sure to take time, go outside and safely observe the eclipse. Put on your glasses, use your welding helmet, whatever safe method you choose, but definitely take time to get off the air and view the eclipse. That's very important. So enough about the SEQP. So that was an event that's scored based on two-way contacts. Pretty standard. People understand that pretty well, I think. The new event we came up with this time was called the Gladstone Signal Spotting Challenge. The folks that are familiar with modes like Whisper, WSPR, and its newer cousin, FST4W, would probably like to participate in this event. Whisper is a propagation study mode where people transmit usually at low power, usually in a few hundred milliwatts, and they will transmit for a 2-minute period, which sends out their call sign, their location, and a few other details about their station, and then they listen for 2 minutes. So this is a contest that's built around one-way transmissions, or beacons, if you will. It's kind of interesting, something a little bit different. Now, when most people think about Whisper, they may be familiar with these types of Whisper maps that shows pairs of stations. There's probably one transmitting station here. I'm just picking one, for instance, AA6CZ, and it looks like he's being received by at least 1, 2, 3, 4, 5, maybe 5 or 6 other stations. But each of those stations, when they hear the transmitter, they record who that transmitter was, where they were located. They record who the receiver was, where they were located, the time, and the frequency. So every one of these little lines in the map is a data point for us. It represents a QSO, and like I said, there's a time, frequency, and location information. So in itself, you may only see 30 or 40 pairs of data on this map, but when we get things really cranked up and we do this for 10 hours, we end up with a tremendous amount of data. Most of this data ends up on three websites, either the Reverse Beacon Network, WhisperNet, or PSK Reporter. To give you an idea, back in October during the annual eclipse, we had about 300 people enter our various contests. Those 300 logs contained over 4,600 unique call signs. So there are a lot of people on the air operating. Not so many of them submitted logs, but we had data created by all these people. In fact, the total number of data points we had for the, I think it was also a 10-hour period back in October, was over 7 million radio spots. And believe me, the scientists love big data. So Hams
Wow.
really came out and did a nice job. We're hoping to do the same, in fact, much better on Monday, April 8th. So those are two of our operating events, but we know there's a lot of hams out there who are kind of technically oriented. They like to build things and they like to tinker, and they don't necessarily talk on the radio that much. So we've got a couple of experiments called GRAPE high frequency Doppler experiments, and I'll explain. This takes a little bit of work and thought to think through it, but basically, if you're familiar, and I think everybody is, with say a station like WWV out in Fort Collins, Colorado, that's our time and frequency station. You listen to it, you hear that 1 second tick, tick, tick. You hear the voice announce the UTC time. It's a male voice in Colorado. It's a female voice coming out of Hawaii. But the other thing these stations like WWV do is transmit on very precise, very precise and accurately on specific frequencies. As an example, WWV does transmit on 10.0000000, whatever. There's like 13 zeros. That's how accurate it transmits. When that signal goes up, gets refracted by the ionosphere, as I talked about earlier, and comes back to Earth, the apparent received frequency back here on Earth changes a little bit. It changes with the height of the ionosphere. That's an effect called Doppler shift. Now, where most people are familiar with Doppler shift, if you're standing on the street and say you hear an ambulance approaching you with their siren, as that ambulance approaches, the audio waves get kind of compressed, so the frequency goes up, the pitch of that siren goes up. After the ambulance goes by you, the audio waves get stretched out, and the received frequency of the audio pitch you hear goes down. The exact same phenomenon occurs with radio waves. So even though WWV is transmitting precisely at 10 megahertz, it's received at 10 plus or minus a few hertz down here on the Earth. And we've designed and we've distributed equipment to measure this very accurately. We call these things personal space weather stations. And I mean, who wouldn't want to have their own personal space weather station? We call these grapes because they work best in bunches. And we've got two versions. The Grape 1 is pictured on the right, the tiny surface mount board that you can build yourself. It's slightly less than 1 by 2 inches, and it receives WWV either on 10, 15, or 2.5 megahertz. It picks just one frequency, very narrow bandwidth, but that's where it receives. I'll also show some pictures of the Grape 2, something brand new that receives on 3 frequencies, and I'll get to that in a minute. This is the picture of the Grape 1, the complete system. It consists of the Grape receiver board, a GPS disciplined oscillator. What this is basically a GPS receiver that receives extremely accurate time signals from multiple satellites, and it uses those time signals to set the frequency on this receiver. The audio is then fed into a sound card, into a Raspberry Pi, and this guy is plugged into the internet. And then once a day, the data from this system, the actual apparent received frequency of WWV is uploaded to a server where the ham researchers can then access it and look what happens to those signals when things like flares or CMEs or eclipses go by. So if you're interested in doing a little bit of tinkering and joining us and doing a little bit of science, and you've got a spare antenna and a good Ethernet connection, a good internet connection, you can take a look about this project and learn about this at hamsci.org/grape. Now I mentioned a Grape 2. These were just deployed actually as last week. These are a little more sophisticated. They receive 3 channels at once. Typically, we expect people to be listening to 5, 10, and 15 megahertz WWV. It's also possible to listen to CHU, the Canadian Time Standard Station, if you're in the Northeast US or Canada. But this Grape is very similar to the other one, except its circuit boards are much more complex. It's really not a build-it-yourself thing. They have to be commercially manufactured. And we really haven't worked out how to make these available to the general public yet. But someday, you should be able to purchase a Grape 2 and build one of these and help us with our data in a very, very significant fashion. Another interesting thing about these grapes is you can actually look at the data and see what's going on yourself. It just doesn't go into a black hole and disappear, and you're left wondering. The folks at the University of Alabama programmed up this website, and these green markers here represent stations on the Grape network, which are uploading data on a daily basis to the University of Alabama server. Now, once in a while, people go off the air and things happen, so their markers turn red. But our hope is, of course, that they'll go back and turn green before long. But anyhow, this is a publicly accessible website. You can go in and look at anybody's data and download it and do your own research if you were so inclined. But one of the features of that website is the ability to plot anybody's data. And this is the data from last October on Eclipse Day from a receiver that was near Scranton, PA. And what this graph is telling us, this is Doppler shift up and down.
Mm-hmm.
Most of the signal is around 0. That means we were receiving WWV right on 10 megahertz, exactly on it. But these little bobbles, these little bumps up and down, represent very small frequency shifts from the exact 10 megahertz. Certain things we see every day are these bumps around dawn. These are called dawn effects. I'm not sure anybody understands exactly why this occurs. So this is definitely an area for research and study. But something interesting to us is when the eclipse occurred, when the eclipse went overhead, that passed from the Pacific Northwest over to Texas, we saw similar shapes in the data when we graphed it that we do during the dawn effects. So I'd spoken earlier how day and night, those transitions are called gray line, and we expected to see the same thing during eclipse. And there we did. We did see some of it. So you can look at plots from a lot of different stations. You'll see the same shape. And that's definitely going to be an area for further research. But it is kind of fun to plot your own data and see what's going on. When we have big coronal mass ejections or big solar flares, you'll see a lot of other interesting things in the data too. And that's what we're trying to figure out.
That's awesome. You can give them direct access to their own data and see what is actually being done. And oh, that's so amazing.
Yeah, that's definitely one of HamSci's fundamental, I guess I'd say, promises that all the data is publicly accessible. And the thing is, too, we may generate this data last October. We're going to generate more in April. It may not get used for months or even years. I mean, somebody may come back 3 years from now, and maybe some strange thing happened, like a satellite exploded. And somebody will say, wow, I wonder if I can see that in the data plot. Well, they'll go back to 3 years and look at our data and look at total electron content or who knows what else they'll look at. But it'll be there for a long, long time.
That's awesome.
Another part of that project, just to know that we though the ionosphere is our focus, we're also concerned about the Earth's magnetosphere. And I think most people, if you watch propagation forecasts, they talk about the stability of the Earth's geomagnetic field. And there is an add-on board which can be remotely basically buried in your backyard, which can measure small changes in the Earth's magnetic field. And this gives the researchers another area of study. They can compare changes in the ionosphere to changes in the magnetosphere, and then and hopefully learn a little bit more about how the electromagnetics and space physics work around our Earth. So to sum up a little bit, we've got the SEQP. We'd love people to get on the air on April 8th. If you're a whisper operator, keep your station going, or maybe if you have not had it on the air for a while, please get it up and going before April 8th. If you're interested in this GRAPE equipment, though we're talking about the Eclipse today, we expect that GRAPE stations to be on the air for months, if not years to come. I mean, we think we're getting close to the peak of cycle 25, but there's a lot of exciting stuff that's going to happen during this solar cycle. So we hope for these grapes to be on the air 24/7, 365 for a long time to come. And then there's a lot of other experiments that you can learn about on our website. I do want to acknowledge, I said earlier that we're a series of volunteers, but it does take money to develop this equipment, to build some of it and get it deployed to certain stations. And a lot of that funding comes from things like the National Science Foundation, NASA, ham radio organizations such as Amateur Radio Digital Communications, and others. So we thank our partners that help fund us. I want everyone to realize too that when you talk about the National Science Foundation and NASA, those are our U.S. tax dollars. So fundamentally, it's the U.S. taxpayer that is supporting us, supporting our research, and we do appreciate that very much. So that's about it. This is a photo I snapped of the 2017 Eclipse with a very, very simple analog recording system. It was basically just a pair of binoculars and my cell phone, but that's what we've got. So we'll definitely take some time and open the floor for questions.
That's a good photo there. Oops, you caught me off guard. There we go. Um, I didn't see a lot of questions here in the chat. We got Colin though. He's over in VK Land, Australia. He's saying his next eclipse is going to occur over in 2028. So that's 4 years away. The time to start getting ready is now, especially on prices on filters and other things for the camera, because it's only going to go up the closer you get to the date. Ask me how I know. I tried to buy some solar filters lately, and they're about 2 to 3 times normal price. Um, but everyone in the chat, if you have some questions, let us know, and we'll go ahead and ask them on air. We are getting ready for the up and coming eclipse here less than almost, well, it's a week and a day away from current recording, and it's gonna be a fun event. And I'm paired up with it's a broadcast pair team, and I am going to be one of the receivers. And what I'm going to be doing a part of the event is I'm going to be receiving, I think on 40 meters is my assigned frequency. And there's several of us be listening, I think, around the states on that 40-meter frequency and with a single transmitter. So during and then after the eclipse, we're going to be recording our audio. Is that correct? And
That's
submitting
right.
it?
Yes. Yeah, we've got a couple of stations transmitting what are called chirp signals.
Mm-hmm.
They're funny sounding audio signals, but they'll basically make a long story short. What they help us do is to calculate the height of the lower side of the ionosphere. And that as we've talked about earlier in the show, the ionosphere is always in motion, and we expect there to be a lot of motion during the eclipse. And by people like Frank participating in what we're calling the time delay of arrival event, we should be able to maybe even measure how much the ionosphere is moving.
That's pretty cool. So what bands are you going to be targeting for that time delay study?
The Well, one of the goals is to have stations near the eclipse path, which you are. So propagation, based on what was tested last October, is 40, 60, and 75 meters. Over the weekend, we did run some tests on 20 and 15. So who knows, if time permits and the bands are open, we may announce what's going on and move up there as well.
Oh man, I can't wait. Um, Anthony says he's got the brisket ready. Come over and get a beer. I'm all there. I'm all there. Vern, yes, I'm going out. I'm going to be camping with Vern. Jason's going to make it out Saturday or Sunday, and we're going to be down there in Fredericksburg, Texas. And we got a friend who has some land out there. We're going to go and camp out, and we're going to have some fun and watch the eclipse. That and hopefully I'll make it back safe because I don't know about y'all, but I am worried about the roads afterwards. Um, yes, man, this is awesome, and Ham Science, you already announced everyone that does help you support. Y'all just though wrapped up a Ham Science event a weekend two ago. Can you tell us a little bit about that?
Sure. Like a lot of, I would call them scientific communities, they tend to hold what we call workshops on a semi-annual or annual basis, and HamSci is no different. Because as we do research, we need a forum to kind of present our ideas and our findings. And the HamSci workshop is held every year, usually in March. This year was last weekend. It was held at Case Western Reserve University in Cleveland, my alma mater, and we had roughly 50 different speakers, speaking most of them for 15 to 20 minutes, taking questions about some of the research that they had done based on the data that we saw earlier, based on these experiments, and in some cases proposing totally new ideas about things that we might try for future experiments. So it's basically just a good it was part social gathering, part technical gathering, and in some afternoons, like on Saturday afternoon, it was kind of a free for all, where we all met in a large building at Case Western Reserve called the Think Box,
Mm-hmm.
and some of us presented what are called posters. We instead of doing a 20-minute talk, we put our ideas together on like a 3 by 4 foot poster. We set them up around the room and kind of had a round robin event where everybody could get around and talk and mingle and discuss our ideas. So it's a very fertile ground for new thoughts on space physics.
And did you mention what time of year that is? Is that every year, like on the third or fourth weekend of March?
Yeah, it's approximately when it is. Depends on when who is hosting it. Last year we were hosted by the University of Scranton. It was a little bit earlier in March because it was during their spring break and it gave us access to their buildings without interrupting the students in their classes. This
Nice.
year we did it at Case, and we're hoping future conferences maybe in the Western U.S., say Colorado, or maybe even the West Coast. But that's the 2025 site is yet to be determined.
Mm. Oh, those are great. I know Jason Ham Radio 2.0, who's in the chat right now. Goes out there every year for that, and I would love to join. It's just I only have so much PTO time right now. But
Well,
uh-huh.
the good thing is we've got people in attendance live, and that's obviously the best way to see it. But Jason is there recording it, and eventually it all goes up on YouTube.
Hmm.
So you can either log in virtually and watch it as it happens, or eventually it'll be up on YouTube and you'll be able to catch it, weeks or months from now. So you can go to our hamsci.org page, look up the workshop, see our agenda, see what interests you, and eventually be able to find it on YouTube.
Awesome, awesome. Yeah, I do watch all the Jasons. I don't watch live. I might need to do that. I forgot there was a live element to that. Is there anything else that you want to talk about since I don't see too many here questions right now?
I think we're good. I would like to say that HamSci will have a booth again this year at the Dayton or Xenia Hamvention. So if some of these ideas interest you, you're welcome to come by and talk to us. We're there basically just to discuss what HamSci is, what we're all about, how people can help us. And we'd of course like to meet some of the people who may have been taking data or built these great systems. And then we can have a little bit of camaraderie around space science. That'll be at the Dayton Hamvention this year.
Awesome, awesome. Do you have a idea when we're going to see like the results of our current study, or are they going to be posted up?
That's an excellent question, and it's the answer is probably years from now. What I've learned, because I'm not a scientist, I'm a retired engineer, what I've learned is the scientific process is very slow. Scientists take great care in analyzing the data because they don't want to make mistakes. And then they take that analysis and put it out to some of their peers, other fellow scientists, and sometimes a private and sometimes a public forum. And those other scientists will critique it. They'll say, hey, you did this calculation, but are you sure about that? Or would you rather look at the data this way and crunch it, bend it, and fold it? And they go back and forth like that. And again, it takes a period of years. So when the official findings come out, I wouldn't be surprised if it's 2025 or after. That's just how science works because they want to get it right. If you put bad science out there, it kind of leaves a bad taste in everyone's mouth, and you know how that would go.
Mm-hmm. Good question just popped up here in the chat. It says, "Where do we go to get the grape system?"
Well, the grape system is not for purchase. The grape one, you could go to hamsci.org/grape one, and that will talk about where to obtain that circuit board. You'll get a parts list so you can order everything from DigiKey, where to get the software, how to program and configure it, and so on and so forth. So it's not exactly a Heath kit. You're not going to get step-by-step instructions, but if you're familiar with and have tinkered with these sorts of things in the past, you'll be able to do pretty well. And like I said, the Grape 2 is brand new. Our grant funded 30 units. We dispersed those. And once we get through the Eclipse, we'll figure out how to make more Grape 2s available.
Awesome, awesome. I appreciate it. Um, Arnold, when will the Grape RX be used for general research after the eclipse, or will it be the end of the project?
The grapes are expected and hope to stay on the air from now until well through 2025 because the sun is always doing interesting things to the Earth by throwing out things like coronal mass ejections, solar flares, and other phenomena. And when those things happen, the grapes can receive it, and we want to record it and save it for future research.
It just kind of clicked on me, and also I'm multitasking with all the producing stuff. But the grapes are an awesome passive system that's always there. So when something happens, you can post facto go back and pull it up and see what happened. Oh, that's so cool. I love that. I might have to build a grape system, or I'll just hang out and wait for the grape twos.
Yeah, it is fun. I mean, I can when I hear through the ham radio press that we had a big solar flare or something, I will open up my own grape Raspberry Pi folders and try to find my own plots for that day. And sure enough, I can usually see the phenomena. And if somebody said, "Hey, a big CME hit the Earth at 1630 Zulu," I'll see those. I'll see my plots at 1630 Zulu take a nosedive,
Hmm.
and know that I received it as well.
That's awesome. All right. Your website is hamstudy.org. I got it here up on the screen. I know I have it also pinned in the chat and also in the description. And for more information about anything ham science, I believe it's hamscience.org, correct?
Hamsci, HAMSCI.org. You got it, Frank.
It's awesome. Well, I also in the description I link to the Eclipse site and the Grape site and also the NASA Solar Eclipse site that you can see where the actual path is and where will you be during the eclipse. And that blue line, I'll just kind of talk about this map real fast, is the totality line, and that's where you're going to get the most maximum exposure to the total eclipse for the maximum amount of time. Between the two red lines is the totalitarian event path. So if you're in between those two lines, you're going to see a totalitarian. It's just a question of how long that it will be. And put your location here, and you'll definitely see what those numbers are. And I did not realize until we started talking today it was going to take a path from Texas north. For some reason I thought it was from the north through Texas, but I learned something today. I agree, Don. Go ahead and hit that like button. I will really do appreciate it. And Arnold says, great, still have to finish the Grape RX. I have all the parts and hope to be done, but with the family. Okay. I'm sorry to hear about the family issues, but hey, man, projects it's awesome to pick up when you have that time. Um, Thank you for coming on, Gary. I really do appreciate it. Thank you for your time and spending your Thanksgiving evening with us. Last chance to say, you got anything else to shout out or like to promote?
Nope. So I just appreciate everyone's participation. Come take a look, learn, and hopefully participate. And that's it, Frank. Thank you very much.
Thank you for coming on and giving us your time. Um, I am Frank Take Radio. I already did that part in the beginning, but thank you for watching. Just a quick reminder, my audio podcasts are out there. This will be this week's audio drop, but there's two audio podcasts that are not on YouTube. So go ahead and go and subscribe to Tank Radio on audio podcast to hear those. Those are great podcasts. Thank you to my Patreons supporters. Thank you for supporting me and allowing me to do what I'm doing here. And thank y'all for watching. I do appreciate it. And have a happy Thanksgiving. Say bye. A quick shout out to all my Patreons who makes the show possible. You can support me by joining Patreon in the link below. And on to Tank Radio.